So let's now discuss another example. That is our example 2 for integration by parts. So if we have, say, the integral of tangent of x dx. So as this time to evaluate, we use my pen first. So we have evaluate this time the integral of tangent inverse of x dx. So the solution, we let u be equal to tangent inverse of x, and then our dx, our dv, so that's our u tangent inverse, and our dv is equal to simply dx. It means to say, if we take the derivative of u, remember the derivative of tangent inverse, that's 1 over 1 plus x squared dx. So if we evaluate dv, means to say our v is simply equal to x. Thus, making it our formula for integration by parts, that is the integral of u dv equals u times v minus integral of v du, granting that our u is tangent inverse of x and our dv is dx. That's equal to u. Our u this time is tangent inverse of x. Our v is x, so let's put x first here. Minus our v is, we'll have x. V is x. And our du, so du is equal to, or du is equal to 1 plus x squared, and now properly dx. Okay. Now if we try to evaluate this, we know that we can rewrite, so we can let u sub 1 be equal to, this time our u sub 1 be 1 plus x squared, so that our du sub 1, that's the derivative of this, will now become, write upon properly, it will become 2x dx. Meaning to say, we can replace our x dx by du sub 1 over 2. So that means to say, we'll have now x tangent inverse of x minus integral of, so our x dx is du sub 1 over 2, and write that as du sub 1, then you can put down your 1/2 here outside, so it will be easier to integrate. So you have du sub 1 over 2, 1 plus x squared. What is 1 plus x squared? That is our u sub 1. This is du sub 1. C sub 1. But what is the integral of d sub 1 over u sub 1? Yes. From here you have x tangent inverse of x minus 1/2. Remember that the integral, recall, the integral of du over u is equal to ln of u plus c. ln of u plus c. So that this one now becomes 1/2 ln of u sub 1 plus c. But what is our u sub 1? That's 1 plus x squared. So x tangent inverse of x minus 1/2 ln this time of, you have 1 plus x squared plus c. Now this will always be positive, so you can simply write x tangent inverse x minus 1/2. We can get rid of the absolute value ln of 1 plus x squared plus x squared plus, and that would be the integral of tangent inverse of x dx. That's your answer here. Okay?